Bismillahirrahmanirrahim. Students, welcome to the session of week 10 of database management systems. If you can listen to me properly, please raise your hands. Okay, thank you. So we were talking about database security in our face-to-face class. And I am going to continue from where I left. So first I'll give you an overview and then I'll continue from the slide from which I left. So we were talking about database security. And I told you about the types of security. So when you want to have security or databases, or we want to protect our databases from different types of threats, so we can secure our databases by handling certain issues. One of the issues is the legal and ethical issues, which is regarding the right to access the information. So who should be authorized to access the information, whether the private information should be available to unauthorized users or not. Then there are some policies issues which are related to the organization or related to the government or at the corporate or higher level. Then the system related issues like which functions should be available and whether the security would be provided at hardware level or software level, and the need to identify multiple security levels. So whether you'll provide the same types of access to everyone or you'll have security levels. So these are different types of securities. Then we talked about the threats to databases, where we had the slide about loss of integrity, loss of availability, and loss of confidentiality. And then we can have to protect databases against these three types of threats, 4 kinds of countermeasures can be implemented. One was access control, the other was inference control, third was flow control, and fourth was encryption. So the DBMS typically includes a database security and authorization subsystem for ensuring the security portion of database against authorized access. There are discretionary security mechanisms and there are mandatory security mechanisms. So the mandatory security mechanisms are concerned about enforcing multi-level security, and the discretionary security mechanisms are about allocating accesses. Is any question? Hara, do you have any question? Any question? Okay. She raised hand, that's why I'm asking. Okay. Okay, if you have any question, you can ask me at the end of the session. So the mandatory mechanisms are concerned about the levels of security, and discretionary ones are the ones about the privileges. The security mechanism of DBMS, which includes the provisions for restricting access, and we have an access control mechanism to control access. Then the statistical problem associated with databases is that of controlling the access to statistical database. So the countermeasure of statistical database security problem is called inference control measures. Another security problem is of flow control, which prevents information from flowing in such a way that it reads unauthorized users. And we can solve this problem by having covert channels, by having some hidden channels. The third issue is about data encryption, which is used to protect sensitive data. The database administrator is the central authority for managing the database systems, and his responsibility includes granting privileges and then classifying users in different levels. The DBA has a DBA account in the DBMS, and they are sometimes called system user or super user, and they have the capabilities to create account, to grant privileges, to revocate privileges, and to assign the security level. So whenever a person or a group of persons want to use a database system, the person should first apply for a user account. So the user account is created and the user is allocated an account ID and password, and the user should log into the database systems by using that account ID and password. The database system should keep track of all the operations the user is performing by creating the login sessions. The login sessions the database administrator keeps the record of all the actions and can maintain a system log. And if any tampering with the database is suspected, you are not sure whether the tampering has been performed or not, you can perform the database audit. So when you do auditing, it means you are reviewing the logs to examine all the excesses, and you are trying to see whether something wrong has occurred or not, some unallowed action or restricted action has been performed or not. So you maintain a database log that is used mainly for security purposes. We call it audit trail. So the typical method of enforcing discretionary access control is by granting and revoking privileges. So you grant them, and if you face some problems, you can revoke those privileges. The types of discretionary privileges are provided at account level, like the VBA specifies the privileges that each account holds. And if it is at the relation level, will be provided for the individual relation or the view. The privilege that the account level applies to the capabilities to the account, and the privileges can be privilege to create schema, to create view, to alter privilege, or to drop privileges. So these are the privileges which are provided. The second level of privilege applies to relational level. So you can include base relation and built relation as well. You can provide privileges based on the rows of the matrix, on the columns, and you can create a matrix for those privileges. And to control the granting and revoking of relation privileges, you can, in a database, assign the privilege of the owner to the owner account. So the owner gets all the privileges, and the owner can authorize someone by granting the privilege, and for this purpose, they use the grant command. So the privileges can be granted to each individual based for select, for modify privileges, and the privilege can be granted on a relation. So you use references privileges on R, which gives the account the capability to reference relation R when specifying integrity constraints. And if you are providing a view privilege to someone, you have to provide the select privilege as well. The mechanisms of use is an important discretionary authorization mechanism in its own right. For example, if the owner of A of a relation R wants some other account to be able to retrieve only some fields of R, so the A creates a view and provides only those attributes to B by granting select on V to B. So you can provide the restricted access to someone else as well. In some cases, it is desirable to grant a privilege to the user temporarily. Then you can grant the privilege, and then you can revoke command, use the revoke command to cancel the privileges. And you can grant your privileges using the grant option, which we have seen before in class. Suppose that B is given the grant option by A, and that B then grants the privilege on R to the third account C with grant option. Then the privileges on R can propagate to other accounts. But sometimes you do not want these to propagate. So if the owner A now revokes the privileges granted to B, all the privileges that B propagated based on that would be automatically be revoked. Like A provided some privileges to B, and B on its own provided those privileges to someone else. So when A is revoking the privilege of B, then all the privileges which B has provided will also be revoked. Suppose that a DBA creates 4 accounts and wants only A1 to be able to create base relations. then DBA must issue the following grant command in SQL. Grant create tab to A1. Now these are different accounts, A1 up to A4. In SQL2, the same effect can be accomplished by having the DBA issue a create schema command as follows. Create schema, example, authorization, the schema name is example, authorization will be for A1 only. So there's different formats for SQL and SQL2. Now user account A1 can create tables under the schema called example. Suppose that A1 creates the two base relations employee and department. A is then owner of these two relations and hence has all the relation privileges on each of them. Now suppose that A1 wants to grant A2 the privilege to insert and delete tuples in both of these relations, but A1 does not want A2 to be able to propagate these privileges to additional accounts. So what it does is it provides grant, insert, delete on employee, department to A2. Now these privileges for insertion and deletion on these two relations will be given to A2. So these are the employee and department tables for which A grants privileges to A2. Now suppose that A1 wants to allow A3 to retrieve information from either of the two tables and also to be able to propagate the select privilege to other accounts. So A1 can issue commands such as grant select on employee department to A3 with grant option. So now A3 can grant this privilege to someone else as well. And now A3 can grant the select privilege by using this command grant select on employee to A4. Now note that A4 can't propagate the select privilege because grant option was not given to A4. So since the grant option was given to A2 to A3, so A3 can give it to A4, but A4 cannot give it on this. Suppose that A1 decides to revoke the select privilege on the employee relation from A3. It used this command revoke select on employee from A3. Now the DBMS must now automatically revoke the select privilege on employee from A4 too, because A3 granted the privilege to A4 and E3 does not have the privilege anymore. So A4 privilege will also be revoked. Suppose that A1 wants to give back to A3 limited capability to select from the employee relation and wants to allow A3 to be able to propagate the privilege. The limitation is to retrieve only the name, birth date and address attributes and only for the tuples with d number equal to 5. So the A1 will now create a view first, create view, A3 employee, this is the name, select name, birth date, address, where d number equal to 5. After the view is created, A1 can grant select on the view A3 employee to A3 as follows, grant select on A3 employee to A3 with grant option. So this is the command for this. Finally, suppose that A1 wants to allow A4 to update only the salary attribute of employee. So A1 can issue grant update on employee salary to A4. So in this way, we can use these commands for grant and revoke. Techniques to limit the propagation of privileges have been developed, although they have not yet been implemented in most DBMSs and not part of SQL. But the techniques are limiting horizontal propagation to an integer number I, means an account B given the grant option can grant the privilege to at most I other accounts. Vertical propagation is more complicated. It limits the depth of granting the privileges. So there are two, although these are not practically implemented, but these are some ways. The discretionary access control techniques for granting and revoking privileges of certain relations has been the main security mechanism. This is an all or nothing method. A user either has or does not have a certain privilege. In many applications, an additional security policy is needed that classifies data and users based on security, and which is called mandatory access control. It will typically be combined with discretionary access control mechanisms. So what you do is that you make security classes. What you will do is that you make security classes Typical security classes are top secret, secret, confidential, unclassified, where TS is the highest level and U is the lowest level. The commonly used model for multi-level security, known as the Bell-LaPadula model, classifies each subject and object into one of the security classifications. Clearance of a subject S as class and the classification of an object as class O. Two restrictions are enforced on data access based on the subject-object classification. Simple security property. A subject S is not allowed to read access to an object O unless class of S is greater than class of O. So we are making classes for both of them and we are allocating privileges to them by using the simple security property. Another is a star property. The subject S is not allowed to write an object O unless class of S is less than or equal to class of O. To incorporate multi-level security notion into relational database, we use attribute values and tuples as data objects. So each attribute is associated with a classification attribute C in the schema, and each attribute value in a tuple is associated with a corresponding security classification. And sometimes we use tuple classification attribute as well. So the multi-level relation schema R with an N attributes will be represented as attribute 1 and classification attribute C1, attribute 2, classification attribute 2. So where Ci represents classification attribute associated with attribute I. Now the value of TC attribute in each tuple C, which is the highest of all attribute classification values within C, provides a general classification of the tuple itself, where Ci provides a finer security classification. In multi-level relation, it appears the multi-level relation contains different data to subjects or users with different clearance levels. In some cases, it is possible to store a single tuple in a relation at a higher classification level and to reduce the corresponding tuple at a lower classification level as well, which this process is called filtering. And in other cases, it is necessary to store two or more tuples at the different classification level with the same value for the apparent key. This leads to the concept of poly-instantiation, where several tuples can have the same apparent key value but with different classification levels. So you can see the same values at different classification levels as well. This concept is called poly-instantiation. In general, the entity integrity rule for multi-level relations states that all attributes that are member of the apparent key must not be null and must have the same security classification. So you can say that we are following the entity integrity rule if you are keeping the values of all tuple at the same classification level. In addition, all other attribute values in a tuple must have a security classification greater than or equal to that of a parent key. This constraint ensures that a user can see the key if the user is permitted to see any part of the tuple at all. So this is the mandatory access control and role-based control for multi-level security. Now some other integrity rules are also there. One of them is called null integrity and inter-instance integrity, which informally ensures that if a tuple value at some security level can be filtered from a higher security level or higher class tuple, then it is sufficient to store the higher class tuple in the multi-level relation. So if you can filter, if you can get the value from the higher security level, then you can, it is sufficient to keep the higher security level value with you. Now comes the discretionary access control. The discretionary access control policies are characterized by a high degree of flexibility, which makes them suitable for a large variety of application domains. The main drawback of this DAC model is their vulnerability to attacks. The mandatory policies ensure a higher degree of protection because we are preventing illegal flow of information. Where mandatory policies have the drawback of being too rigid, in many practical situations, discretionary policies are preferred because they offer a better trade-off between security and applicability. Now there is a trade-off between discretionary policies and mandatory policies. The mandatory policies becomes too rigid. So, but for flexibility, you have to use a combination of them in practical situations. Now comes the topic of role-based access control, which is called RBAC. This emerged in the 1990s as a proven technology for managing and enforcing security in large-scale systems. Its basic notion is that the permissions are associated with roles and users are assigned to appropriate roles. So what you should do is that you should create roles, or you should destroy roles, and you should use grant and revoke for roles. It appears to be a viable alternative to traditional discretionary and mandatory access controls. It ensures that only authorized users are given access to certain data or resources. So what you do is that you maintain a role hierarchy in a natural way of organizing rules. So the person or account at a higher level will have more authority than the person at the lower level. Another important consideration in role-based access control systems is the possible temporal constraints that may exist on roles, such as time and duration of the role activation and time triggering of a role by the activation of another role. So using the RBAC model, it's a highly desirable goal for addressing the key security requirements for web-based applications. The discretionary access control and mandatory access control models lack capabilities which are needed to support the requirements for web-based applications, so which role-based access control mechanisms provide. And this was basically helping us out, or help us out, in e-commerce and web application environments which require elaborate policies that go beyond traditional DBMS. So in an e-commerce environment, the resources are to be protected are not only traditional data but also knowledge and experience. So you want to share your data as well. A related requirement is the support for content-based access control. So this is another option. Another access control policy for e-commerce and web can be about the heterogeneity of subjects, which require access control policy based on characteristics and qualifications. So you maintain user profiles, and then you maintain a set of credentials, and you allocate privileges according to the role and according to the accounts. Now comes the topic of statistical database security. Statistical databases are used mainly to produce statistics on various populations. The database may contain confidential data about individuals, and users are permitted to retrieve statistical information on the population, such as averages, sums, counts, maximum, because user will be interested in getting this data. A population is a set of tuples of a relation that satisfies some selection condition. So when you are using that condition, so it gives you some data which is a population. Statistical queries involve applying statistical functions to the population of tuples. For example, we may be interested to retrieve the number of individuals having or the average income in the population. For this purpose, we require income of all the people, all the users in the account, and then you will be interested in getting the count or sum or average of that. So these queries are called statistical queries. So it is the DBMS responsibility to ensure confidentiality of information about individuals, and you provide privacy protection of users in these cases. You have to allow for statistical queries very carefully. Now comes the topic of flow control. Flow control regulates the distribution or flow of information among accessible objects. A flow between object X and Y occurs when a program reads value from X and writes values to Y. This is called flow. So we need to have flow policy, which is to specify the channels along which the information is allowed to move. So we can maintain two classes of channels, confidential and non-confidential, and we allow all flows except from C to L. Like if you are allowing the confidential flow to non-confidential flow to non-confidential class, so this can be dangerous. You make covert channels which allow a transfer of information that violates the security of the policy. The covert channel allows information to pass from a higher classification level to a lower classification level through improper means. So there are two categories of covert channels as well: storage channels and timing channels. The storage channels, in the storage channel, the information is conveyed by accessing system information, or what is otherwise inaccessible to the user. The timing channel allows the information to be conveyed by the timing of events of process. We use encryption and public key infrastructure to secure communication. We use encryption algorithms, and we use different public and private keys to secure our data. And there is a data encryption standard as well, which is developed by US government, which provides end-to-end encryption between channels, between the channels of sender and receiver. Okay, I have moved ahead. These topics are not part of our content, although I have told you about flow control and covert channel as well. But the topics till the slide number 50 are included in your course. The rest of the topics are not included. So this is the last slide number 50, Introduction to Statistical Database Security. The remaining topics are not part of this. Although you know about encryption now, we need to cover these. Topics till slide number 50 are part of the course. Okay, now I want to know if you have any question from this. Okay. Amal, you are asking about which case study? Yes, you have to read the topics in this week till this topic, which is Introduction to Statistical Databases, which is page number 860 of your textbook. So chapter 24 is included till page number 860, till this topic, Introduction to Statistical Database Security. From this chapter, in exam, if you are talking about exam point of view, you can be asked some short questions about the differences between discretionary and mandatory access controls, and you may be asked to write queries to grant privilege or revoke privilege. Such questions can be asked. Okay, I'll try to give you some questions about this before your final exam. I'll give you some sample questions before final exam for preparation. Okay. Okay, guys, thank you very much. Now I'm turning my microphone off, but I'm available over here. If you have any question, you can ask me in the chat panel. Okay. Thank you very much.